we've seen that free body diagrams are incredibly important. Actually, any diagram in dynamics and statics and physics, those are very, very important ideas that we've got to keep that. So let's look at some free body diagrams just to kind of get you grounded. We're going to look at a couple of different examples, and then we're going to look at a couple of fundamental problem examples just looking at that free body diagram. So the equation of motion in our Cartesian vector notation is going to be the sum of the forces in the I direction, sum of the forces in the Y direction, sum of the forces in the K direction. But remember, mass is related back to that ratio. So it's a scalar function. So it's going to look at the acceleration in the X direction, acceleration in the Y direction, acceleration in the Z direction. When you're doing your free body diagrams, you want to establish your coordinate system and draw the particle's free body diagram showing only the external forces, because we're hoping that all those internal forces are being dealt with together. And when we get into some other more complicated things, then we got to kind of take those into account. Think of our rolling cans down an inclined plane. If I have a solid cylinder, it's going to behave differently than if I have a can that's filled with chicken noodle soup. And that's going to cause that moment of inertia to change a little bit. But for right now, we're looking at my object as a solid object. We're talking about representing that object as a particle, which means it's going to act through its center of mass. So in this case, I've got an inclined plane. Remember, physicists and engineers love inclined planes because that's really going to get us what we want to have. So I've got my inclined plane. We're going to choose our coordinate system. So remember when we dealt with inclined planes, a lot of times it was better to choose a parallel to the inclined plane or perpendicular to the inclined plane. And that gave us a lot of information and helped us deal with our coordinate system. So we're going to be able to utilize that. So I've got a box that's being pulled up by a winch using a cable. So we can do this because this is really going to help us out, because when we look at it in perpendicular and parallel, I've only got a one-dimensional motion problem. Parallel to the inclined plane, right? That makes it a heck of a lot easier. So my acceleration's only going to be parallel to the inclined plane. I'm not going to have two different components. I'm going to simplify my life by choosing that coordinate system. So we're going to draw our external forces. We're not disregarding friction here. So I have to have my friction, I've got my normal force, I have my tension, and I have my weight. Ultimately, when we pull this up, it's going to be in a one-dimensional motion parallel to the plane, and we're ultimately going to have that acceleration upward being pulled by the winch. So let's look at another one. Let's look at a bar. So we've got a bar that's on a conveyor belt. Our winch is a little different here, but because this is tension in the rope, we can simplify our problem. So I've got tension in the rope, I have the weight down, I have my normal force pointing up, and I'm ultimately going to get acceleration in the X direction. So let's look at another one. So here I've got another one. I've got tension in the rope, I've got the weight of the car acting down. What I haven't put in here, and I will put in here right now, let me come back here just a second. I've also got my normal force, okay? And in statics, we see that that normal force, right? And I'm going to go ahead and type that in. I've got a normal force, and depending on how I want to look at the problem, if I'm acting as this is just one box, my normal force would be against those wheels. So I can add in that normal force. Similarly, down here, I have my normal forces, and let me add those in. I've got a normal force between this block and that block, and I have a normal force between the ground and the block. So I've got two normal forces, so I'm going to copy this so that we have it. I've got a normal force here, and I have a normal force down here. So a lot of times we're going to have to make sure we include all of our forces that we're going to want to take into account during our problem. So those free body diagrams, essential, Absolutely essential. And I'm telling you guys, utilize your paper, utilize a piece of paper. Don't try to do these strictly on the screen because it's going to make life a lot harder on you. So you want to look at those free body diagrams.